Good morning all. We are discussing Unit 5 that deals with NMR and ESR. We have already studied what is the resonance condition in ESR. Now let us see what is meant by hyperfine interaction. Hyperfine interaction in ESR. Or what is the origin of this hyperfine structure? The origin of hyperfine structure. The hyperfine structure in ESR it arises due to the interaction of unpaired electron with the magnetic moment of nuclei. We can say that whenever there is an interaction of unpaired electron with the magnetic moment of the nuclei. So, if there is an interaction between your electron with the nucleus, or in more precise way we can say if there is an interaction between the unpaired electron with the magnetic moment of the nucleus, anyway if there is an interaction between the electron and the nucleus, then the ESR line will split up into components. That is called this hyperfine structure. For example, if a nucleus has a spin I, if the nucleus has spin I, then the ESR component, the ESR spectral line will split up into 2I plus 1. ESR spectral line will split up into 2I plus 1 levels. So, there is a further splitting of ESR spectral line. What is the reason for that? The reason is the interaction of unpaired electron with the nucleus. So, like electron, the nucleus has spin. If the nucleus has a non-zero spin I, then the ESR spectral line will split up into 2I plus 1 levels, and it is only possible this hyperfine interaction is only possible if the spin is non-zero. If the nuclear spin is non-zero. For a non-zero nuclear spin I, the ESR spectral line will split up into 2I plus 1 levels. Now let us consider a nucleus of spin half. Let us consider a nucleus of spin half. Now we have already defined that if the nucleus has spin I, then your ESR spectral line will split up into 2I plus 1 levels. Now for a spin half nucleus, the ESR spectral line will split up into 2 into 1 by 2 plus 1. This is equal to 2 levels. That is, each ESR spectral, each ESR line, that is each ESR line will split up into two. Let us revise the previous diagram. An unpaired electron in a zero magnetic field. When the magnetic field is applied, your level will split up into two. This corresponding to ms equal to half, and this corresponding to ms equal to minus half. Now, if there is an interaction between this orbital electron and the nucleus, and you assume that the nucleus has a spin I, then each ESR line, each ESR level will split up into 2I plus 1. Now, if you consider a nucleus having spin half, then each ESR energy level will split up into 2. That means here this ESR level will further split up into 2, and this also further split up into 2. Now, if we consider nuclear spin I, if a nucleus has spin I, then we can define nuclear spin quantum number as Mi. If Mi is the nuclear magnetic spin quantum number, then you have Mi, this is half, this is minus half, again minus half, and half. Now, please remember that your Mi quantum number is represented like this, that is plus half minus half, and in the bottom portion it is represented as minus half and plus half. Now, here we have a selection rule. That is delta ms equal to plus or minus 1, and delta mi this is equal to 0. Please remember this selection rule if the ESR hyperfine interaction is asked as a question. So, you have to, and in these situations what happens if a microwave radiation strikes on the molecule? H nu. So, there is a transition, but this transition should also follow the selection rule. So, whenever there is a transition between these two levels, your delta ms, that is ms initial minus ms final, should be plus or minus 1, and delta mi equal to 0. So, the transition will be like this, 1 by 2 to 1 by 2. If you consider a transition from mi 1 by 2 to mi 1 by 2, delta mi equal to 0, and in each level your ms is half. So, if you take delta ms 1 by 2 minus 1 by 2, this is plus 1. Sorry. and the second transition is this. So, in both case, these selection rules are satisfied. So, this represents the energy levels and allowed ESR transition when an unpaired electron interact with the nucleus of spin I equal to half. This is remember, this is specially for nucleus having spin half. Now, let us consider another example. Let us consider another example. Let us consider nucleus spin 1. Now, for a nucleus of spin 1, your ESR energy level will split up into 2i plus 1 level. Each level will split up into 2i plus 1. And for spin 1, this is equal to 2 into 1 plus 1. This is equal to 3 levels. So, how will you draw the ESR splitting? Yes, initially B not equal to 0. Your electron is placed in an external magnetic field. Before the magnetic field is applied, there is only one energy level, and when the field is applied, your energy level will split corresponding to ms equal to half, then ms equal to minus half. Now, here, now what happens when this electron having unpaired spin, when the electron having spin half which interact with the nucleus of spin 1. So, each level will split up into 3 components. So, this will be this level will split up into 3. Okay. Split up into 3. So, here you can write Mi as (1 0 minus 1), then minus 1 0 1. Here also the selection rule is delta ms equal to 0 and delta mi this is equal to delta ms this is equal to plus or minus 1, delta ms equal to plus or minus 1, and delta mi m suffix i delta mi equal to 0. So, that means your first transition from 1 to 1 1 to 1, this should be straight line, 1, then for second one is 0 to 0, and third one is from minus 1 to minus 1. And in all these cases, we can see that delta ms, in this particular case, we can say that in this situation, we can say delta ms this is equal to plus 1. Why? Because this represents absorption. and delta mi is 0. Here this is specially for nucleus with spin 1. Okay.